Okay guys, so for today we're going to be focusing on the slope formula. Now the slope formula can also be known as something called the rate of change. What that means is we're trying to find the average change between given points on a linear graph. So for here, let's first figure out what each part of our formula means. The m in our formula represents slope. This right here, x2 minus x1, this represents the different x values of our two given points. So in this case, this can mean the x value of point B and the x value of point A. What that means is we're looking for the difference between two x's, or the difference between two x's in the chain or the horizontal change. And the next part represents the difference between the two y values in given points. And here this can represent the y value of B minus the y value of A. So again, write this down. We're looking at the difference between two y's, or the vertical change. You may have heard of the formula being referred to as rise over run. The amount you have to go up, the amount you have to go to the right to meet your point. So let's write it out. We've seen it before as our slope is equal to rise over run. But that doesn't tell us anything mathematically. It's an excellent way to remember it, but we have to be able to explain numerically what is going on when we say rise and run. When we say rise, we're talking about the vertical change between the 2 points. So write down y2 minus y1. And again, for run, it's the same concept. When we're talking about run, we're looking at the horizontal change between 2 points. So write down x2 minus x1. So what we're looking at here is in our formula, we're finding the vertical change divided by our horizontal change to get our rate of change. So let's go ahead and give it a try for this example right here. For this example, we have point A. Point A is at 1, 1. And point B is at 1, 2, 3, and 1, 2, 3. Those are your respective points. Now, a good practice to have here is before we even jump in to plugging into our formula, we should label our points to find out what goes where. So since A is my first point, I'm going to label this my x1 and my y1. Which means for our B, your B should be labeled x2, y2. So in this case, what I've just done is I've said 1 is labeled as x1, 1 is labeled as y1, 3 is x2, 3 is y2. Now that we have everything labeled, we can start plugging back into our formula. So in this case, our slope is equal to 3 from y2 minus y1, which is 1, divided by our x2 of 3 and our x1 of 1. When you simplify and solve algebraically, you should get a slope of 2 divided by 2. But any whole number divided by exactly itself is just equal to 1. So what this is telling you is that for every point you go up, you must go exactly 1 to the right. The same thing goes for the next point. That is your rate of change for this example. For the next one, the next one has a bit of a longer rate of change. And if you take a look here, unlike our first example, this one goes through different boxes in an uneven rate. So we're expecting a fraction from this. Before we start, write down your points. So your points for this are A has a point of -2, since I went 2 to the left, and I have to go 1, 2, 3 down. So since I went 3 down, that means my point is -3 for my y. And for my b is at 1, since I went 1 to the right, and I have to go 1, 2, 3, 4, 5 up. And since I went 5 up, I have a positive y value. And again, before you start plugging in, label your points. A is our first point, so that means -2 is x1, -3 is y1. B is your second point, which means x1 is, or 1 is your x2, 5 is your y2. Everything is labeled, so now plug it in. Your slope is equal to your y2 minus your y1. Now notice here I'm putting my negatives in its own parentheses. A common mistake here is that when you see a negative value, to simply put it in and treat the negative as a subtraction sign. But we have to understand that negative numbers are their own values, and this minus sign here must always stay. So make sure when you plug this into your formula, you still are subtracting the negative every time. For your next part, we have our x2 minus our x1. Now the trick here is that whenever you're subtracting a negative, they each turn positive. So instead of subtracting a negative, you will be adding a positive to each x2 and y2 values. So 5 plus 3 is 8, and 1 plus 2 is 3. Remember what I said about that fraction? It looks like we were on the right track. And if you take a look here, we can check ourselves. From A, I'll go up 1, 2, 3, 4, 5, 6, 7, 8, and then go to the right 3 times. 1, 2, 3. The slope checks out. And if you'd like, put a little green check mark near it. Makes me feel good whenever I do. Alright, so on to the next part. You will not always be given graphs when you work with slopes. In fact, when you're given the point values, it's often easier because then you don't need to figure out what each value is for it. So for here, let's focus on labeling our points. We have to find the slope of points 2, 3, and 5, 5. So again, I always go with the first listed point for being my x1 and y1. So for here, this one is my x1, 3 is my y1, which means that 5 is x2 and 5 is y2. Now that they're labeled, plug them into your formula. You have the slope is equal to the difference of y2 minus y1, and again, each of these are being pulled from up here, divided by your x2 minus your x1, 5 minus 2. And you should get a slope of 2 over 3. As easy as that. The one downside is you cannot check it on a graph, but you're more than welcome to plug this into Desmos if you're ever curious. Let's take a look at the next problem. So we have to find the slope here of -1, and 2, -4. Again, we have x1, y1, and x2, y2. So, plug them in. Your slope, again, is the difference between y2 and y1. Again, make sure that your minus sign doesn't take over your negative. They must both be there. And now we have to do x2 minus x1. Your slope for here, once you change all signs to positive where they need to be, is -3 over 3. Now, even though your numerator, or the top part of your fraction, is negative, you could still simplify this to have a negative slope. Because again, despite this negative, 3 divided by 3 is still 1. The only difference is that you have a -3 divided by 3. So rewrite your slope as -1. Next, the second to last example is -3, 1, and 1, 3. Again, x1, y1. And we have x2, y2. Plugging it into our formula, we have m is equal to y2 minus y1 and x2 minus x1. Remember, when you have these negatives subtracting from a positive, change your signs. Now you have 2 over 4. And since this doesn't divide cleanly, we can find a common factor between each one. I can simplify for 2 for both of these. 2 divided by 2 is 1. 4 divided by 2 is 2, leaving your slope to be just 1/2. And finally, we have a slope of 2 points, -6 and 0, and 0, -6. With -6 being x1, 0 being y1, 0 being x2, y2 versus -6. Plug it in again. Your slope is equal to -6 minus 0, and we have 0 minus -6. So your first inclination here is to assume that your slope is just going to be -6 over -6, but this is where our placements matter. Even though we have a -6 and a -6, they don't end up that way because of our rules of subtracting fractions. Change the signs, and your full slope will be -6 over 6, just like our example from 2. We have a negative value divided by a positive value. So simplify it out to just get a -1 right here. And that's how you do slope.